Hey everyone, and welcome to another fluid properties lesson. This is the second of 5, and today we will be discussing pressure. So to give you a bit overview of the 5 topics, the previous video discussed the fundamentals of fluids, and this video will be discussing pressure. Future videos for the third topic will be stress, the fourth being viscosity, and then lastly the fifth being surface tension and capillarity, to cover up the fluid properties section. So let's get right into the pressure category. So fluid pressures are measured with respect to two pressure references, zero pressure and atmospheric pressure. Pressures are measured with respect to a true zero pressure reference, which is also known as gauge pressure. Standard atmospheric pressure is considered to be equal to 101.3 kPa, and kPa is abbreviated as kilopascals. So absolute and gauge pressures are related from this first equation. Atmospheric pressure is the actual atmospheric pressure that exists when the gauge measurement is taken. It is not standard atmospheric pressure unless this pressure is implicitly or explicitly applicable. Also, since a barometer measured atmospheric pressure, a barometer pressure is synonymous with atmospheric pressures. And a vacuum measurement is implicitly a pressure below atmospheric pressure. It must be assumed that any measured quantity given as a vacuum is a quantity to be subtracted from the atmospheric pressure. Vacuums are always stated to be positive values. So the pressure section is fairly quick and simple, so we are going to go right into the first example problem. So let's see. A vessel is initially connected to a reservoir open to the atmosphere. The connecting valve is then closed, and a vacuum of 65.5 kilopascals is applied to the vessel. Assume standard atmospheric pressure. What is most nearly the absolute pressure of the vessel? So for starters, let's write out what we are asked to find along with what information we have been given in this word problem. So we are asked to find the atmospheric pressure, and we are given a vacuum gauge pressure, which is 65.5 kilopascals. From these two pieces of information, we can determine that the formula that we will need to use to determine the atmospheric pressure is the second equation I previously just introduced. And that is the absolute pressure equaling the atmospheric pressure minus the vacuum gauge pressure. Since the atmospheric pressure is a standard value of 101.3 kilopascals, we will subtract that by the vacuum pressure of 65.5 kilopascals, and that will get us an absolute pressure of 36 kilopascals. So for this example, A is the correct answer, being 36 kilopascals to be the absolute pressure. That concludes this video on pressure under the topic of fluid properties. I hope to see you in the next video where we will be reviewing the stress and future videos as well. So I really encourage you guys to like the video and subscribe so you don't miss out on future content regarding fluid properties and other engineering related categories. Hope to see you guys there. See ya.